Welcome friends. In the last lecture we have discussed some part of first chapter of surveying. In that we are studying surveying 1. In the previous video we have discussed regarding the definition of surveying. After that we have discussed the principles. We also discussed regarding objectives of surveying. We also discussed objectives of surveying. So surveying is defined as the branch of civil engineering in which the relative positions of points on Earth's surface is determined with respect to linear and angular measurement. So these two measurements are used to determine the positions of points on ground. So this is the concept of surveying. We have also discussed the principles of surveying. First principle of surveying was to work from whole to part. And the second principle of surveying was to locate a new station with at least two measurements from relatively permanent and fixed points. So this was the second principle of surveying. I also explained this principles of surveying in the previous video. We also discussed regarding the objectives. Objective means we can say in Marathi uddesh. So objectives of surveying are to prepare a map, to measure the area, then to measure the distance. So these are the objectives of surveying. Today in this session we will discuss the types of surveying. Primary types of surveying. Okay. So this is the primary classification of surveying, in which the surveying has two subdivisions or two types. First one is plane surveying and second one is geodetic surveying. Okay. So now we'll see what plane surveying means. The branch of surveying in which the curvature of Earth is not considered is called as plane surveying. The branch of surveying in which curvature of Earth is considered is called as geodetic surveying. So the branch in which curvature is not considered is called plane surveying, whereas the branch of surveying in which the curvature of Earth is considered, it is called geodetic surveying. So in this, curvature is considered. So now we have made two types based on the curvature effect of Earth. We know that Earth is having a spheroid shape. Okay, so this curvature of Earth makes big difference while measuring the distances on the Earth. Whenever we are measuring the distance for smaller length, suppose we have taken such portion of Earth, and if we consider this portion of Earth, we can see that I will draw this portion here. You can see that this portion nearly looks like a straight line. So that's why the error due to curvature of Earth is negligible for this. So that's why in such cases we consider Earth as a plane surface and we measure the distances excluding or not considering the error due to curvature. So such type of surveying is called as plane surveying. Now if this type of surveying is called as plane surveying, it must have some limit, means up to which distance or up to which area, we should consider Earth as a plane surface. From or the value beyond which the Earth's curvature will make a big difference in measurement. So, what is the limit for plane surveying is the question. So, the plane surveying is carried out for the area which is less than 250 kilometer square. Whenever there is when the area is lesser than 250 kilometer square value, then the type of surveying which is done, it will be called as plane surveying. Okay, so for the area lesser than 250 kilometer square, the curvature of Earth is not considered. So that type of survey will be called as plane surveying. When area of Earth or the area of measurement exceeds the value of 250 kilometer square, then we need to consider the curvature of Earth, because if you consider this length of Earth, I will draw that length here. If you consider larger length, you can see that this length is not equal to the straight line's length. We know we can see this is curved line, not a straight line. So that's why if you measure distance considering Earth as a plane surface, you will get wrong measurement. So that's why we need to take this curvature into consideration while going for larger measurements. So that's why in geodetic surveying, the curvature of Earth is considered, and geodetic surveying is done for the area which is greater than 250 kilometer square, which is greater than 250 kilometer square. So these values are somewhat different in many books. Some of the books have given the area, the branch of surveying in which area means plane surveying can be done for the area lesser than 260 kilometer square. Some of the book given this value. Precisely some notes of IES had given the value of 195.5 kilometer square. So for our reference we'll take 250 kilometer square. Okay, so this is the classification of surveying based on primary classification of surveying based on curvature of Earth. So have you understood this? So I will once again revise. Plane surveying is the branch of surveying in which curvature of Earth is not considered and it is done for smaller area. Geodetic surveying is the branch of surveying in which curvature of Earth is considered and it is done for the larger area which is beyond or which is greater than 250 kilometer square. So when the Earth's surface is plane, considered as a plane, then it is plane surveying. When Earth's surface is considered as a curved surface, then it is geodetic surveying. So now we'll move towards the next point. Now we'll see the classification of surveying. This is the classification of surveying done based on curvature effect or the area under consideration or the extent of survey. Okay, so next type of classification will be based on the instrument used. In survey. So this is based on instrument used in survey. So there are many types of surveying based on instrument used. The first type is chain survey. Second, chain and compass surveying. Third, theodolite surveying. Fourth, plane table surveying. Fifth, tachometric surveying. there are some more types like photogrammetry. Then then we can take an example of total station survey. Okay, so these are the types of surveying based on instrument. In the chain surveying, only chain is used. Chain and compass surveying. In the chain and compass surveying, we use chain and compass in combination. In the theodolite survey, we'll use theodolite for the angle measurement. In the plane table surveying, the plane table is used for surveying. In the tachometric surveying, instrument named tachometer is used for surveying. In the photogrammetry, the photographic camera is used for taking photographs. So and in the total station is the instrument used for the surveying. So these are the types of surveying based on instrument. Now we'll see what are the units which we are using in the survey. As I have told you that in the survey we have to take measurements, so all the units related to the measurements are needed to be known in this branch of civil engineering. So all in all branch means knowledge of units is necessary. So units of length measurement, in which sometimes we use different measurements for site and different for documentation. In site condition, the traditional methods of measuring length in foot and in inches is considered. So for documentation, most of the time we use meter, centimeter. For measurement of area, we have acres, meter square, centimeter square. This is used for sheet plan. So there is one more R and hectare, unit of area. So these are the units of length and area. So we should know the conversion between these units. Now it is not necessary to know all the time because we have the unit converter in our mobile, but as a civil engineer we should know some of the standard conversions in order to get basic idea of measurement or to convert the measurements as per the need of the customer. So that's why to understand the customer we should know this conversion. If you don't know, you are having that in your mobile phone, so that is not as important to know this. The angular measurements which we are taking will be in degree, minute and seconds. Okay, so angle is represented in degree, minutes, second. So the representation of angle will be like for example 10 degree, 20 minute and 30 second. So this is how we'll represent the angular measurement. This is 10 degree, 20 minute, 30 second. So for minute single dash is used, for second double dash is used. So this is how the representation of angular measurement is done. After that we'll see, as we are taking measurement, the measurement in the surveying, we know that every measurement have some error. So first of all we'll see what type of errors can be arised in the measurements in surveying. So we'll see types of errors in surveying. So there are three kinds of error or types of error in surveying. Okay, so first one is mistake, second systematic error, and third one is accidental error. So this is also called as cumulative error, and this is called as compensating error. These two errors have one more name. The systematic error is also called as cumulative error, and accidental error is also called as compensating error. Okay, so now we'll see how this mistake happens. So the mistakes are the errors which are arised due to the inexperience of the observer or the writer, the person who is entering the who is making entry of the measurements. So the mistake may happen due to the inexperience of observer, the person who is taking the reading, or the person who is noting the reading. So that may happen due to misjudgment of the observer. That may be happen. Carelessness is the second reason because of which mistake can be happen. Due to some natural adversities, fog or wind, the mistake can be happen. Then the next is the mistake can be happen due to the wrong observation. The another reason of mistake is the inattention, or one can also say that confusion in mind. So these are the reasons because of which mistake can be happen. If this error of mistake is not known, or the mistake is undetected, in that case this is a serious error. So that's why to eliminate such type of error, what care is taken, that is every measurement should be independently checked. Means if one observer had taken one reading, then second observer will independently cross check that reading. So that is what the way of eliminating this mistake is. To eliminate the mistake, one observation should be made by two observers. So in that case, this error due to mistake can be eliminated totally. Now we'll see the second type of error, that is systematic error. A systematic error is the error under the same condition will be of same size and sign. Means the systematic error this type of errors tend to be of same size. for that measurement, and the sign of error also remains same while taking that measurement. So that's why these errors are called as systematic error. For example, I'll tell you one example of systematic error. So if one chain we have which we have taken for measurement is of 20 meter, but one link of that chain is missing, due to which this 20 meter chain has error of 20 centimeter. So this the chain which should have length of 20 meter is having length lesser by 20 centimeter. Means this is the 20 meter chain is 20 centimeter short. Now if you take measurement with this chain, with this defected chain, you will get error of 20 centimeter in every measurement. So that's why this error this error will be of it will have same sign for that particular measurement. So this is how the systematic errors happen, and this error tend to accumulate. So that's why these errors are also called as cumulative error. So that's why this error can be eliminated by mathematical formulas. Okay, so mathematical formulas, when we come to know about the error in instrument, so such type of error can be eliminated. Okay, the third type of error is accidental error. Accidental errors are accidental error. Accidental errors are those which remains after the mistake and systematic error is removed from the measurement. Means the error which remains after mistake and systematic error, then that error is called as accidental error. The reason of accidental error cannot be